Hello, welcome everyone. Welcome to another episode of Xa Talk Show. Today we are going to code several languages. So let me show you. So we are going to continue the speed comparison of a seemingly simple task of find and replace of 1,000 files in a directory. And we are going to compare Golang, Python, Emacs, Lisp, and Wolfram language. So we did, in the past 3 days, we did all that. And today the main thing is we're going to code Golang from scratch. I'm going to show you and I'll explain along the way how to do that. And along the way I'll talk about some interesting things about algorithms or programming or these different languages. Okay, so we're gonna continue today, and in particular these are some of the topic I want to go over today. So one is we're gonna improve our Wolfram language code. That's one thing. And we're gonna explain some very interesting phenomenon when you do multiple pairs of find and replace. Okay, that's one thing. And then another thing is that in the past we've done speed comparison of 1,000 files, small files. Each one is like 1K or 2K. But this time we are going to do one huge file. Let's say one 10 megabyte file. Let's see which language is faster, because they are quite interesting, different. The find and replace. So one single huge file, and we are going to also code PowerShell to join 1,000 files into a single file. Let's explore how do you do that in PowerShell, which is a fantastic new shell, better than Bash, the 40 years old Unix package, PowerShell. Okay, then lastly we're gonna write a Golang version today. So today is going to be 90 minutes, probably around there. So if you are watching offline, play it in 1.5 or 2 times speed. I'm going to do it leisurely. I don't want rush, because every time I rush, the result is not so good. So 2 people watching, fantastic. Okay, so let's begin coding today. So on the pink window, I'm using Emacs and Softlight keys. You can search those words, you'll find my website. And I'm using Expose keyboard right here, and the Ultimate Hacking keyboard. So full of macros. You see showing browser. You can find my keyboard page just by search for it, and you'll see I recommend Expose. It's fantastic. And also this I also recommend. Okay, I talked about that many times. So let's begin coding. Okay, so let's see what is this keyboard bar close. Okay, the Xa Talk Show today. First of all, let's go to yesterday, because we have several code there we want to copy over. So yesterday, so you can see this is the PowerShell for copying directories over 1,000 files, and measure the timing of each different languages. And here is the find replace pairs we want. And here's a result from yesterday. Very interesting result. You can see, there's a first time result and second time result. They have different timing. Because part of the reason is because when you do it the first time, it takes the time to load those 1,000 files to memory. So once you do it once, some of the files are in memory. So the second time is much faster. The second time is also faster because many of the pairs no longer exist in the files. Therefore, when you do it the second time, only some of the pairs you have to replace and write to disk. So reading file and writing to disk, these are very costly operations, so very slow. So we try to, when we do this speed comparison, we try to eliminate the time to read from the disk or to write to the disk. That is why today we try to do one single huge file. So anyway, the speed from yesterday, very interesting result. You can compare the first time Python Python is fastest, then Emacs Lisp, then Wolfram language. But if you compare second time, Emacs Lisp is the fastest, Python become the slowest, and Wolfram language, there's a huge inefficiency there. I'm going to explain, and we're gonna improve it. This inefficiency because our coding error, nothing to do with Wolfram language. Also, there's something else I want to explain about the very interesting issue when you want to do multiple pairs of find and replace in sequence. There's unexpected result. I'm going to explain, and that Wolfram is doing much better because essentially the Emacs, Lisp, and Python, their code is just wrong. If you really want to do it correctly, you have to double the code actually. But Wolfram, one single line does it. Okay, so yesterday here's the Emacs Lisp code, about 20 lines, 15 lines. Here's the Wolfram language code, 10 lines or one single line. Here is Python, the most voluminous, the most verbose. Okay, Python. Okay, so now, we copy them over. So let's copy the code over. So I'm using Xafly keys and XHTML mod. So we want to copy all these, copy, close, showing browser. So this is today, right? Let's put it here. And remove all the syntax coloring so we can see the plain code here. Okay, so first stop is the Wolfram language. Okay, so here are the things we want to do. Okay, first of all, let's do the copy the files over to the PowerShell. So we have the files we can do the find replace on. Okay, so let's go to PowerShell. Okay, pop it out. Wait, make a backup, pop it out. Okay, so let's go to this directory. Okay, that exists. And by the way, this is the Emacs manual, Emacs Lisp manual. You can download from the, search it, you'll find it, 1,000 pages. So we're gonna start PowerShell. Magnify, and okay, we're gonna remove those existing files because we changed it. Okay, and now we're gonna copy over. Okay, open. Now it's a fresh copy. Okay, now pop this back. Now let's do the Wolfram language. Okay, let me explain something we have to do Wolfram to improve it. Okay, so here is the Wolfram language code. Now let's see. Video check, audio check. Am I doing good? Say hi, guys. Hello, Guybrush. Okay, video check, audio check. Okay. Yeah. So Guybrush says, for your information, you might to check the code from yesterday. The Python code includes files in subdirectories. Oh, you are correct. Thank you for that, pointing that out. We need to fix that. Although this directory is just one single, there's no subdirectory, so that doesn't really matter. But anyway, this is a good point. Thank you. Oh Jesus, what's today's task? That's very annoying because every time I just explain, I just spend 10 minutes explaining. So anyway, let's continue. You can just go to the link on the YouTube, description. You can see these, today's topic that I just talked about. Okay, let's back to Wolfram language. So here is the Wolfram language that does it. So here is a list of pairs, replacement pairs. That's the syntax of the list, and each element is actually a rule. That's kind of a special thing, but anyway, you can just consider it as a list of pairs. Okay, find string, and then we have replace string. Okay, then all you have to do, you define this function, process file equals to that function, and here's the function body. The parameter is file path. Then you say module. Module is a local variable. So in this local variable, you have this file content, x content. You just read string that gets the whole file's content into a string. And here's the new content. Okay, so new content equals to string replace content and this list of pairs. So in Wolfram language, all you have to do is just call string replace. It'll do a bunch of them, one shot. That's very, you don't have to write a loop, or map or for each. It's just, that's one of the characteristics of Wolfram language. Any function, it has maximum utility. So one shot you can replace all these pairs. So you save it to new content. Now the last part, if old content equals to new content, then do nothing because there's no change. Otherwise you write string, which write to file path and new content. Okay, very simple. So this is a function that process each file given a file path. Then all you have to do is you just scan is like for each in JavaScript or mapc in Lisp. So you just apply this function to a list of file names. To get a list of file names, that's what you do, file names, star HTML. So you get all the HTML files. Okay, but now this part is extremely inefficient. Because if there's no change, typically this file content is huge, right? 2K or 3K kilobytes. So if there's no change, you are trying to compare, this huge string. That's very slow, inefficient. So rather, what you want to do, what we did in Emacs, Lisp, and in Python, is that to determine if a file changed. You don't want to do this, okay? Very inefficient. Instead, you want to know, given each of these find string, do they occur in the content? Okay, if they occur, then that means you are going to do some replacement. So there's file change. Okay, so now we want to given a string and another string, we want to find whether the string exists in the file content. Okay, that's what we want to do. So how do you do that? I don't remember offhand. So let's go to Wolfram. Just search for it. You'll find my Wolfram tutorial. Then you'll see a page on the most useful string functions: join string, substring, occurrence. Okay, so delete substring, format string, string to list, list to string, string to number, list all string functions. Okay, so let's search for occur. Occur is not there. What should it be? Let's see. Let me start Wolfram language notebook. So, I forgot that. That's a Python documentation. Let's start Wolfram language. Sam, hey Sam, don't worry about it. Okay, don't worry about it because I tends to be, often I came out as rude. So Wolfram language started, and by the way, you can do, if you want to know all functions that contains the word string, that's what you do. So which one is it? You want to know if a string contains some other string. Okay, so let's see. So usually that would be find or something, read string, string casts. Okay, so we should do this faster. String count, okay, string contains q, okay, that will do. String contains q yields true if part of the string matches string pattern. Okay, that is one of them. String contains q, string match q will also work. Okay, let's just start to code it. Okay. Okay, that returns either true or false. Any function that ends in q returns either true or false, nothing else. Q means question. Okay, so string contains string match can also do it. What's the difference? I'm not too sure. String path, string position. Okay, string q, string. Okay, basically those two. Okay, or string start q. Okay, they don't care. Okay, yeah, these two functions. So let's have a look. Let's see how do they differ, which one is more appropriate, more efficient for our purposes. So let's look at their documentation. String match q, test whether string matches string pattern. Okay, so basically you want a string pattern. Okay, yeah. And what about string contains q is also a pattern. Yield true if any string matches string suffixation. Okay. Basically they are similar. It's just that the difference is that, okay, so by the way, there's a ignore case true. Okay, by default it's false. Okay, string contains q. They are similar. The difference is that I believe string match q, the pattern must match the whole thing. I'm not too sure. But let's, we can, since we have the Wolfram language, we can quickly test it. Actually, we have a lot of things to do, so we shouldn't waste time by, ABC something. Okay, so a pattern. Here's how you do it. Okay, let's see regular expression. Before we do that, let's just say something. Okay, false. Now what if we use a pattern? So we want a regular expression. Okay, regular expression, and we want to say any, let's say sum. Okay, let's see, does that work? You see, no, because you need, when you call string match, it needs to match the whole thing. So what you can do is you can say anything one or more plus, and anything one or more plus. You see? Okay, so we don't need string match, we just need string contains. That's the appropriate one. Okay, good morning, Greg Doc. Okay, string contains q, so here is the string, which is the content, and so we need to test. Okay, here should be find string. Okay, so we need to kind of do a loop through them. Okay, how do you do that? Can you give a list to the string contains so that you don't need to do loop? Yes, exactly. Like I said, this is a characteristics of Wolfram language. You don't have to do a loop yourself. You can just, so all you have to do is to take the first part of these string pairs. Let me show you how to do that. Okay, so that's a pair of strings, which is a list of, you can think of those are technically called rules, but you can just think of them as list of pairs. Okay, so you can map first. Let me show you a short syntax. So you want to map the function first to find replace pairs. Okay, that's what you want. So the full syntax for that, we are using a shortcut here. You see /@ but the full syntax, if you want the readable form, more intuitive for beginners, then you do that. Okay, they are the same thing. So we want to so let's use the more readable for beginners. So you see, so here we'll return a list of the find string. Okay, and in fact we can just do that. So if this is true, then that means the content contains the find string and we need to do find replace. Okay, so if this is true, if this is true, let's see, string contains yields true if any substring matches any of the pattern. Okay, so if this is true, so we don't want the testing of equality. Okay, let's just do that. If that's true, then we have to write toString, else null. Okay, that should make it faster. Wait, let me show you the speed difference. Okay, so we compare two different so here's one way, here's a more efficient way. We can comment out one of them. Let's comment out this one for now. We're gonna test the speed. So, but here, the new content, do we still need it? Yes, we need it. Okay, why don't we do this? Hold on a second. Okay, so that's one way. The other way is that you just remove that. Okay, and you don't even need new content. Okay, so new content, you don't need it anymore because it only occur one time here, so you can just say here. So it becomes so extremely simple, and you don't even need this. Oh, you do. So yeah, you do need this variable x content. So here's one way, here's the second way. They differ by this checking whether you need to write to file. Okay, so comment this out. Now let's run this. Okay, copy the code, put it back. Now let's put the code into a file. So the file is here. Open it. This is from yesterday. Select all, paste. Okay, save, close, copy the line back to shell, paste it. So we're gonna test the timing now. Okay, do it. From yesterday, it's going to be 6 seconds. Yeah, so 6 seconds. And run a second time. The timing yesterday is Wolfram language 2.7 seconds. Okay, there it is, check. So this is algorithm from yesterday by comparing the whole file content. Okay, now let's let's use the new algorithm. So comment out the old, new, and let's start over. Remove all the files. Copy the files over. Now run it. Good morning, guys. Say something, okay? Say something. It's still 6 seconds. What the fuck? So before it's 6 seconds, so it did not save much time. Let's run the second time. The second time is even longer. What? Wow, fuck, the second time is even taking longer. Hey, void machine. So we have a problem. God, this is so annoying. Each time we do something, there is a why is it so this string comparison? Okay, so basically it's telling us that this string comparison is faster than checking if the content contains any of the fine string. That's incredible. That's, how is it possible? I mean, how? I don't understand. Is there something else they changed? New content. I don't understand. If new content equals to old content, do nothing. Otherwise, write to file, right? And over here, if I don't understand. Why should let's go to the file. Let's see, did we make the changes correctly? I think so. Yeah, this end of line got screwed up. Yeah, that changed. Let's search for that. Yes, you see, each that happens, we did 1, 2, 3 times. If we run it one more time, then it's gonna be 1, 2, 3, 4. Yeah. So it worked. Oh wait, we yeah, but it okay, it's new content. Okay. I don't understand. Now let's try to make these two to be exactly the same. Okay, so let's just replace this if by this. I mean, okay, let's just replace this line by this. Yeah, let's put them here. Okay. So now let's try this. Okay. start over. Fuck. Yeah, because there's no file there. Remove nothing. Remove them. Copy it. Now run the Wolfram language code. Do it. 6 seconds. 6 seconds. Okay, 6 seconds. And do it second time. 1.7 second. Oh, 2.6. Why is it 2.6? 2.6. Oh yeah, that's right. So yesterday it's also 2.6, right? So okay, that's good. Now let's use the new algorithm. Okay, in fact we don't need this null part. Okay, in fact this line, we can also change it so that we don't need this null. All you have to do is this means not equal. Okay, so now both of them have the same structure. Okay, comment that out. Okay, now let's do over. Remove all. Copy them. Run Wolfram language. 6 seconds. Yep. Okay. Now second time should be faster, please. 2.7. Same. Same. Interesting. We didn't improve any speed. It looks like these two code have the same speed for some reason. .7. I wonder the result will be different. I mean, these two lines will make a difference when you have huge files. That is, we're gonna join 1000 files into one file. Are you guys there? Say something. Okay, so anyway, so here is our Wolfram code. Okay, copy it, close it, and wait, make a backup, close it, and let's go to the Wolfram language part. Delete this. Okay. Yeah. Okay. Hello, you feel. So great. Let's continue. So okay, we tried to improve the Wolfram language, and seems the speed is the same, no difference. Okay, now let's do the next thing. Shall I explain the sequential problem first, or let's write a PowerShell. Let's do this thing. Let's write a PowerShell to join 1000 files into one file. Okay, let's do that. Okay, PowerShell. So let's start here. When PowerShell join all files into single file. Okay, in Unix, all you have to do is you just say cat, and that's all you have to do. If you are in Unix, Bash, Linux. But in PowerShell, I think that will work too. So let's try it. cdxx the. So you see we have do it again. So let's say cat star HTML. Cat is an alias to, let me show you, okay. Cat is an alias to get content, but I'm not sure it will do the same thing as Unix join. Let's redirect to, let's say XXX, okay. Let's see if that works. It's taking too long. Oh, it worked. So let's drop into the directory. Let's see if it worked. Okay, so go open it, go all the way to the bottom. There it is. PowerShell, open it. Oh my god, it there's a problem. It added extra line breaks. So this file xxx is 7 megabytes. Okay, I want to do this properly. I don't want just, I don't know what's going on there. So, because in PowerShell, you have this operator pretty much like Unix, but there's some differences. It will add, for example, you have seen, it will add this, let me show you, it will add these line breaks. So I'm not too exactly sure how or why, but you see, apparently each line breaks becomes 2 or 3. So yeah, I don't know. So anyway, close it. Now let's go to PowerShell and let's see if we can do this properly. Okay, so my PowerShell tutorial, I spent like a year almost to write it. Check it out, okay? Complete, no nonsense, technical tutorial and easy to understand for beginners, okay? PowerShell tutorial, okay? Meanwhile, let me just mention now that if you like my, my videos, my stuff, pay me, okay? That's important. I want also to to just like every YouTuber, tell you to support me, Patreon me, Amazon gift card or PayPal, okay? Thank you. Okay, so let's go back to PowerShell. So we want to know how to join all files. Let's see. Let me see if I can quickly do it properly. PowerShell, programming PowerShell. So you can get all files. Then what do you do? Join string operations. Okay. String operators. Okay, so you have length and join is plus, but now you have a collection of file path. You want to actually, the easiest is just to look at the PowerShell cat documentation. So cat is get content, okay? So you can see get content. So you can type help cat and online. Then you'll go to the online. Online is better, the web version, because you have the formatting much easier to read than this bunch of, the Unix tradition. So, okay, so get content, examples, get the contents of a text file, limit the number of lines, get content returns. Example, get specific line, get last line, get the contents of an alternative data stream. No. Get raw content. Okay, raw content we might be interested, so that it doesn't add, the line return. Okay, so you can say raw. Okay, use filters with get contents. Yeah, so this way, if you use the filter option, it will be significantly faster than if you just use the, the shell glob. That's a tip. Okay, yeah, significantly by several seconds. When you use any ls or the, you want to use the dash filter, because anyway, that's a good tip. Get file contents as a byte array. Okay, I don't know. Delimiter. Delimiter encoding the default value is UTF no boom. Okay, that's good. Exclude filter. Yeah, we wanna use that. Force will override the read-only attribute. Okay, so I think I know what to do. Force will override the read-only attribute or create directories to complete a file path. Okay, yeah. Include literal path raw, ignores new line characters and returns the entire contents of file in one string with the new line preserved. That's what we want, okay? So first of all, let's just try that. So let's see, cat filter, okay? Then you wanna say raw, that's right. Then this part is also tricky, because when you do that, that is actually equivalent to, let me show you, okay? When you use this that's actually a alias by some mechanism to the let me show you, print, okay? So string, okay, value types, PowerShell, programming PowerShell, value types, string, we want print, okay, data structure, loop and iteration, input output here, print to string, print to screen, okay, and write file. So let's check print to screen first. Write output, print to screen or send it to the pipeline if there's a pipe, okay. Okay, suppress command output, okay, so we want maybe write output, echo, right. Now let's check write to file. Set content, okay, that's the proper way. Okay, so we want to pipe it to set content. Let's double check for sure. No new line, do not add that. Encoding default to UTF-8. Okay, set content. Okay, and no new line. And the file name. Okay, something like that. Close that. 5x, that's right. Do it. Command get content at command pipeline position 1, supply values for the following parameters. Path. Oh, okay, we forgot, Control C to cancel. So we need, let's copy this to Emacs. I'm gonna check the comments, okay? I'm gonna read the comment in a minute. So let's the PowerShell, yeah, so yeah, so cat, you just say a directory, okay, that. Do it again, escape, paste, do it. Get content, unable to get content because it is a directory. Please use get children instead. Fucking idiotic. How complex can it get? Wait, so there is an example of get specific line, get the last line, get the content of alternative data stream, get raw content, use filters there. Okay, so oh yeah, so you have to say path. Okay, so this will be, let's just do it here. Paste, do it. Fantastic. So this is how you concatenate all files, in Lisp. Open it, refresh, open it. Okay, but we got this fucking new line problem. God, new lines, lots of issues. The new line convention between Unix, Mac, and Windows. Let's do it again. Let's do it without the raw. Let's see. Do it. Reverting buffer. Close it. Is it done yet? Close it. I think Emacs stuck. Okay. Damn, you don't have an article about Mike Hawk. I don't know who that is. Here's a problem. You see? Now, if you say no new line, yeah, God. Now it becomes like that. No new line. Literally. Cancel. Now Emacs stuck because, okay. Herodo says, just an unrelated question. Have you met company mod in Emacs? Have you? Yeah, of course I have used it. I don't recommend it, So first of all, are you using soft-like keys or not? Answer. Okay, if you are here, answer. Are you using soft-like keys or not? Okay, it doesn't matter. Instead of company mod, I would just recommend using a brief. Okay. But you can surely get it to work. Okay, so let me close this. Emacs now stuck. Okay, how many people are watching? Am I doing good? Oh God, we have a lot to do. 2 people, 5 people. And the Emacs now stuck. I didn't understand soft-like keys. Oh, that is my package. Okay, so anyway. Yeah, so you can use company mod. It's pretty good. So if you are not too familiar with Emacs, I can recommend it. Yeah, but setting up is also a little bit complex. But so there's no easy answer. So let me just say company mod is pretty good. But setting it up takes some know-how, okay? You just have to persist. And I don't use company mod because I find the user interface annoying and too slow. So instead, I use a brief. Just search for Xali Emacs brief. You'll find how to. I use a brief, and I also use what's called hippie completion. So if you just search for this Emacs stuck, search for Xali Emacs completion, you'll find my discussion about several ways and how to go about. Okay, that's basically that's that. Emacs stuck. Now close. This is a major critical problem with Emacs. When you have a file that's one single line, Emacs becomes unresponsive. Every operation, when you press right arrow key, or whatever you do, it takes several seconds to actually know about what you are trying to do. That's a problem. You see, this command we just did that combined 1,000 files into one single one, and now and no line breaks, and now Emacs is freaking out. We might have to start a new Emacs. Let me give you another tip about Emacs. I have my Emacs set up so that there is no state that will interfere with Emacs startup. So I can start up another Emacs right away without asking question. So you can try that yourself. Start a new Emacs. See if it asks you, because there's already an instance, do you want to something, yes or no? Okay, if it do that, I don't like it. It's no good. Okay, I mean it's also good, but it depends on your workflow. I don't want that. So I can start any multiple instance of Emacs without it asking me if I want to start it because there's already occurrence or something. Anyway, so I have now several Emacs. So, but anyway, the old one seems not working. Yeah, so now the old one is back. Okay, so now let's try again. This time, just filter only files starting with X. Okay. So now refresh. Now it's only 19 kilobytes. Okay, open it. Yeah, now it's much smaller, but still one single line. But now we can, let's see what is the, let's remove the no new line. Okay, do it. Okay, if you do that, then you get this repeated new line. So what if I say now we say raw? Okay, then we get this really problem. Wait, is it because all these files? Oh, because they are fucked up. Okay, we have to do this refresh. Okay, remove all of them. Because it's in use. Fuck. Remove them. What in use? Is it that close Wolfram language? Okay, close Wolfram language. Don't save. Close it. Now remove it because it's in use. What is in use? Nobody is using it. Let's see. Pop it back. I don't think anyone is using it. Refresh. Yeah. Close. Yeah, fucking idiotic. Oh, because the current directory, you see, we are in the directory, so we want to go up. Now, remove. Okay, now if we open it, you see it doesn't exist. Wait, the directory doesn't exist at all. Let's go to it, go down. Let's delete the backup. There's no XX. Okay. Now copy them over. Okay. Refresh. There it is. Okay, now open one of them. Okay, it's good. Now let's close. Now let's do the PowerShell. Let's see. That no filter, no new line. Let's do that. Let's see. Wait. Let's add an X here. So we concatenate all files starting with X. What? Oh, you have to CD to it. Okay, so let's do this. Concatenate that directory. Okay. There. So we don't have to CD to the do it. Done. Now let's go to it. Refresh. Oh, go here. Here's a file. Open it. Fantastic. Beautiful. That's how you do it. And now let's rename the file one big file. So hold on a second. We want to copy all xx.big. Okay. And yeah. So this is how you do it. It should be 7 megabyte, this file. So let's open it. Go up one directory. There it is. 6 megabyte file. Open it. Fantastic. Okay. 127 lines. Okay. Close. Okay. Copy the file path. This one delete. Okay. Close. Now here is a big file. Let's make let's put it here. This, yeah, wait. Okay. So this is the large file we want to test. Okay, open it. Yeah, close it. And now we can, what we do, we test the Wolfram language again. Let's see how does it make any difference. Okay. So let me see the comments. Just like escape key in all terminals. Thank you for the comments, generous comments. Smartest Turkish person. Just use VS Code. Emacs post online. What happens to when that happens to ICG and Web Beautify? Yeah. Okay. So now we have one big file, and you know, we completed this task. Okay, so And now, and that's done this way. Now we want to test the Wolfram language to see there's a speed difference when you have one big file. Okay, so let's open the Wolfram language file. So the Wolfram language file is this one. So now the file path is that. What's so originally input file, so let's change that to file, input file. So instead of that, you just say, instead of scan, you don't need that. You know, instead of scan, you just say that. Okay, so now let's go back here. Let's run a Wolfram code. So Wolfram code is this line. Time it. 2 seconds. Okay, so when you have one single file, then it's much faster. Do it again. 1.8 second. Okay, do it again. 1.8 second. Okay, now that's using this first algorithm, compare file content. Okay, so remember the timing is 2.4, basically 2 second, 1.8. Okay, 2 second first time, then 1.8. Now let's refresh. Remove them all. Copy the files over, and now cut them together. Okay, and now let's do the Wolfram language, but with this new check if it contains algorithm. Do it. 2 seconds, okay, first time. 1.8, same thing, yeah. Okay, that doesn't really matter. Okay, so that is for that. Okay, so so let's return them to the way they are. So okay, so that's the Wolfram language code. Backup, close. Okay, now let's do the next thing. Explain the sequential replacement problem. Okay, that's very interesting. Where's Ruby version? Hello, George. George, I have shortcomings in Ruby. I don't know it well, so the Ruby version relies on you. So please do post your Discord solution. So tomorrow also we'll test it. Okay. Now let me explain this very interesting problem about sequential replacement. Okay. So the problem, you see, we are replacing several pairs of strings, find and replace strings. Now, there's a very interesting problem. Okay, so let me show you. Where right now, in all these languages, Wolfram language, Python, Emacs, Lisp, they are all incorrect except Wolfram language. Wolfram language by this let's put the code here. by this single line of code is correct. All the others, Emacs, Lisp, Python. Let me put the code here. Okay. So let's paste it there. Color the whole buffer. Make a backup. Show in browser. So this Wolfram language, essentially one single line, does it correctly, while the Emacs, Lisp, and the Python, they are actually incorrect. And what is the issue? Let me show you. So you go to xrd.info and search for find replace. Okay, very interesting issue. So I have so many here. Find replace feedback loop problem. So, suppose your input string is ABCD, as simple as that, your input string, and your replace pair is A to C and C replaced by D. Okay, A to C, C to D. Now, if you are going to do this sequentially, then you'll get DBDD. But if you are going to do it, let me see, how do I explain this? A, B, C, D, A to C, C to D. So A to C, so you should have C starting with C, so you should have CB, then C becomes D, so you should have CBDD. But however, when you do it sequentially, A becomes C, then you start over, then the first C becomes D, so you get DBDD. That's what, so the result, A becomes D. That's not what you want. So this is like a feedback loop issue. And typically this is not what you want. When you have a string find replace pairs, if the find string doesn't occur in original, you don't want it to change. And this happens in real life when you want to, for example, encode the ampersand character. So you have to read this. Yeah. So when you want to replace, when you want to encode any of the, for example, in HTML, the characters you need to encode are that, and ampersand. You want to encode them as ampersand less or equals to, less than equals to. You want to encode them as that and that. Right, so you have three pairs. The first one you want to replace by that. The second one you want to replace by that. The third one you want to replace by that. So you have three pairs of replacement, but if you do them sequentially, then you're gonna fuck up your encoding of that, because that ampersand, that less than equal, less than sign becomes ampersand LT, but when it comes to ampersand, that ampersand becomes AMP again. So you got fucked up. So this is a very interesting issue, and the way our current algorithm, in Emacs, Lisp, all have this problem. So, but not Wolfram language. Wolfram language, when you do this, it doesn't have this problem, but this problem happens when we do in Emacs, Lisp sequentially, and also in Python, because you just loop through the find and replace pairs. So how do you solve this? In fact, to solve this, you have one way is that by checking the find and replace string, checking that is it possible that they will form a new string that will happen in subsequent find string. That's one way to make sure that doesn't happen. If it doesn't happen, then you can do them sequentially. Usually that's the case when all the find strings are different and there's no and their replaced string. It's a bit complicated because when you find some string by another string, then this new string have neighbors, right? So you have to consider the new string's neighbor. Do they form a new find string in a later sequence? If they do, you got a problem. So one way to do it is check out if that you are going to create a new string that happens in the subsequent find string. Another way, one general solution, you don't even have to check the input, is that you first you do this find replace by replacing each find string to some intermediate random string that will never happen in the text. Let's say random string that will not happen in the text. Then you replace those random text by the desired replacement string. So if you do this way, it's going to double your time, your algorithm, double the time it takes. So that is the issue. So this is a big point for Wolfram language. Wolfram language, they solve this problem internally. I do not know what algorithm they use. There are other algorithms, but gets very complex because alternative algorithm is that when you do the find replace, you have to mark in the content. Every time you did the find replace, you mark their position to store their position so that your program knows this part should never be changed again. So that gets very complex. So that's a big point for Wolfram language. Of course, if you actually want to do them sequentially, you can just nest this function, nest this string replace function, which is also very easy to do. So anyway, that's the issue. So like I said, this is a big issue. This is a big and practical issue. You don't want this ampersand to be fucked up. This is not just theoretical issue. It's actually real world issue. So the proper algorithm is actually for this Emacs, Lisp, and Python. We have to for each find replace pair, we have to create an intermediate string for them to replace two. And that I did in my find package. I demonstrated before, but let me show you one more time. Okay, so let's open the this directory. So let's say I want to replace that. Okay, the word that. Let's magnify. Okay, so I want to replace the word that by that 1, 2, 3. Okay, enter, and it asks me a directory, yes, and asks me a pattern for the file names HTML, directory depth starting with 0 to 99. Write changes to file, yes. Fixed case, yes. Fixed case in replacement, yes. Make backup, yes. Okay, this is the find package written in Emacs Lisp. So you can see all these are done. Okay, now if you drop to the directory, refresh, you can see you have the backup. And let's open one of them, search for that. You can see it becomes that 1, 2, 3 there. So you see this fantastic. By the way, you can see all those ampersand. That's why it's important when you want to these things. So what I'm trying to say is that let's go to the source code of XAR. XAR find. Okay, so you can see I have the algorithm that replace them to intermediate pair. So you can see here, find replace text. The depth, so yeah, literal replace, wait, where is it? Okay, so oh, not here, wait, yeah, that's not this one. So the not in find package, okay, because find package only do one pair at a time, so you don't have this issue. But the package I'm talking about is this one, replace pairs, okay. So in this one, because in this is for Emacs Lisp coders, so you can open it. I can show you. You can search and find it. Replace pairs. It allows you to write a, find replace multiple pairs by this single simple syntax, as opposed to you have to write a loop yourself. You can just do it just like Wolfram language. So if you have multiple pairs of find replace, so you got the issue of the feedback loop. So I solve that problem here by using a intermediate string here. So you see it generates a temp map points. Okay, that's interesting. Which does make the code more complicated fairly, because when you generate intermediate replacement string, then you got the problem. What string should it be? If you're gonna have a random like UUID, which is like 24 characters, that's going to make your algorithm significantly slower, because if you have, let's say, 1000 find replace, now you are adding 24 characters, 32 characters for each pair. So that's interesting, issue. Okay, so that's that part. So are we going to, 3 o'clock, 4 o'clock, right now it's 80 minutes. So I guess we can now do Golang, shall we? What do you guys think? Okay, we did the PowerShell. We explained the sequential replacement problem, which is let me put the links here so we can see it. Okay, and yeah, replace pairs. It's here. Okay, so sequential replacement problem. Yeah, it's here, this article. Feedback loop problem. Okay, so let's see what's next. Test on one single huge file. We did that with the Emacs. Now shall we do it on, we need to write the Golang version. And if we test on one single file, huge file, okay, shall we, so now we have two choices. Now we do all these languages, test their speed on one single huge file, or we start to write Golang version. Which one do you guys want? Say it, okay? We're gonna do, yeah, we need to make progress, so we're gonna do one of them at least. Probably write a Golang, okay? Say something, guys. Okay, let's do a Golang version, okay? Yeah, so let's okay, cool. Let's start. Write a Golang version. Find replace multiple pairs from scratch. Golang, yay. Okay, Golang, I haven't coded Golang for a long time. So Golang, every Golang file, you need this template. So let's explain what we're gonna do. So just like others, we're gonna need to, let's copy some of it. Okay, so we're gonna need okay, find replace multiple pairs in a directory, and we need the input somewhere. So first of all, how do you define multiple pairs? So the pairs we want to replace are something like that. Okay, so Golang, every Golang needs these templates. Now, how do you represent? So we need the nested pairs. It can be a struct or it can be a nested array. So let's go to my Golang tutorial. I haven't coded Golang for a while. Let's just copy our code actually. So because there's already a code I've written. Work directory, which what we need that, working a directory. We also need to read file, but there is a code already written, examples, find string, find replace there. So we're gonna borrow, here. So here, it's pretty elaborate. So the to skip file list, find replace pairs. Okay, we need this. This is struct. Oh, Jesus. So here, find replace pairs, it's going to be this means it's an array. Okay, it's an array, and you're gonna declare the type. Oops. So here we're gonna declare the type, which is a struct. Struct is just like a hash table or dictionary, but with fixed keys and fixed keys. So here we declare a type struct with the key find string and replace string, and their value is a string type. Okay, yeah. So we declare the struct. Then here we declare a variable whose value is a array of find replace pair, the struct. So array of the struct pairs, and so we can start to, for example, the first string is here. Okay, and the replace string is that. So we're gonna need multiple pairs of these, 4 of them. Okay, so here will be that. Okay, let's do it this way. Then lambda becomes okay, then number becomes okay, then we don't need this part. So declare struct and a slice. Okay, it's actually a slice. Okay, so we got 4 pairs of find replace pairs. Okay, then we need to, okay, then what's the next? So we declare the find replace pairs. Let's clean them up a little bit. So we need the input directory. Okay, so we need var input so Golang syntax, is that right? I think so. Open it. So yeah, so that's input directory. Then we need to declare a function. I mean, define a function that takes a file path and do the replacement. Okay, so let's just copy and copy and paste. Where's our function to? Where is it? Oh God! Let's just copy it. So here is our function. Okay, not too bad. Function do file takes a parameter path, which is a string, and then output nothing. Jesus, I forgot how do you declare a function that output nothing. I suppose that's the way. Okay, so you content bytes, you read the contents by calling os read file. Okay, so you need a bunch of import shit. You know, you don't need nothing like that in Wolfram language. I suppose, yeah, you need format, yes. Actually, not really. Okay, you need to print. Yeah, sometimes you need I/O file system. Yeah, you probably need all that. Time you probably don't need. Okay, let's just leave it. Okay, so read file, that when you do this, it gets you a array of bytes. Now check error, then contents. You turn array of bytes into a string. So wait a minute. Are you doing this with? So we are not using a array of runs, which is an array of Unicode characters, slice of Unicode characters. Because in Golang, you have the issue of string versus slice of bytes, which is mutable. String is not mutable, but you can turn a string into a slice of bytes, which is mutable. Or you can turn it into a slice of runs. Each run is the Unicode. Run is in Golang, run is just an alias of meaning a character, Unicode character. So string is not mutable, meaning that every time you change something, it regenerates a whole string very slow. So you want to turn a string into a slice of bytes or slice of runs. And so if you want to understand that, I have that fully written out here. So, but what did we do here? So in Golang, every function that reads a file or any regular expression function, there are typically 3 versions. One version just works on a string, another version works on a slice of bytes, and another version works on a slice of runs. so very cumbersome. Which one to use depends on your purpose. If all you do is reading file, not writing or not changing anything, then just use string, immutable. But if you do want to change, parts of it often, then you want to use a slice of bytes. If you are doing, internet streaming or video streaming, you want the bytes. You don't want characters. But if you are doing text processing, which is our case, you do want runs, which slice of characters, because with bytes, each character may be 1, 2, 3, 1 to 4 bytes. You don't know how many, so you want to use slice of runs. Okay, and here is the the explanation. How do you convert them? So, but our code, what are we doing? So we are reading it as bytes. Okay, array of bytes. Then check error. Then we turn the bytes into a string. Okay, that's the content. We turn it into a string. Okay, now let's go back. What is this code do? Script to find, replace multi pairs. Okay, so it's actually so it does replacement as well. Okay, so it turns the bytes to a string, then change equals to false, then for this is a for loop for each of the pairs struct var found equals to string.index content pair find string. Okay, so if it's found, so Golang, if it's not found, it returns -1, which is kind of annoying. I mean, because of those low-level languages, they do that. So if it's not -1, meaning it's found, you found a find pair, some find string, then content equals to string.replace. Okay, so this algorithm so far is just like our Lisp and Python. So when it's found, you replace it strings.replace. Okay, strings is the package name. So replace is a method. Then you put the content there and pair find string and pair replace string and -1. I forgot what is -1. Anyway, so if it's found, you reset the content, then you set change to true. Okay, and you do this for each of the pair. Okay, so far so good. Now if it changed, then you need to write to file. Okay, so we don't need this print. Remove the print. And if write to file should be always true. Okay, so okay, it's not found here, so actually let's just remove that. So if changed, then just do this. Okay, now if do backup, we don't care if do backup, so remove that too. So if changed, we write to file path, turn the string back to a slice of bytes. Okay, then write file permission. That's a fucking Unix shit. You see, this is what makes the difference in high-level languages and low-level languages. So because in Emacs, Lisp, in Python, in Wolfram language, we don't see nothing like this. Like, what the fuck is this? Well, but Golang is a low-level language. But even low level, you don't you shouldn't have something like that. 0.66644. That's actually an octal notation. for the Unix permission. Fuck. But because Golang is from Rob Pike and he's a Unix fanatics, so he adopted the Unix, thing, a cryptic thing, as part of the Golang. So you write to file, you have to specify this permission. And of course, this permission doesn't exist it's different in Microsoft Windows, in Mac OS, or in other operating systems. It's just a Unix thing. Okay, so anyway, so if changed, we write file, then there's an error, usually very tedious in Golang. Everything returns an error. Golang returns 2 values, then anyway. So if changed, you write to file, then return nil is the function. Yeah, so return nil. Okay, so that's the do file function. Okay, so then now our job is to traverse the directory. Okay, so in the main part here, we need to list all the directories of this input, all the files, and apply do files to each one of them. Okay, how do you do that? So here is the main. Jesus, another big chunk of stuff. Copy. Okay, paste it here. Magnify. Now let's deal with this. Okay, script path, error path. Okay, we don't care. That's for reporting, like reporting which script called. We don't care. So printing, it's printing out the report time. File path, script path in directory, file regular, file rejects filter. We don't care. Actually, we do care. We want only HTML files. Write to file, we don't care. Do backup, don't care. File list, we don't care. We don't have print slice, file list, we don't care. Find replace pairs, don't care. Okay. Now, if length file list is greater than 1, of course, then do it. Okay, so where is our file list? We don't have file list. Okay, in this script I do have a file list. You can add that's when you want a specific list of files you want to do find replace, because otherwise you'll just do every file in a directory using a regular expression to filter out, extension or whatever. But sometimes you just want specific list of files. Okay, so that's what this file list is for. Okay, and we don't care. So therefore remove all that, and just this part, and don't need that. Okay, so now we just do work directory input. Okay, so input, we need to change the name. Go to top. The Golang convention is typically with short names, in contrast to Lisp or Wolfram language. Usually you have very long names, very descriptive. In general, functional programming languages, you have long, fully descriptive names. But C and Golang, you have very short names. So now we walk the directory, in directory, and pwalker. Now what's pwalker? Okay, so pwalker, search for pwalker. Oh, we have to, oh God. So in Golang, in order to walk a directory, you have to define this walker thing. Yeah, you can't just Yeah, you have to. Okay, so let's define this walker thing. P-walker takes a file path, then takes some, yeah, this takes, you know, anyway, so, shit. And then we have that. Let's just ignore, we don't care. And maybe we do care, so shit. So anyway, so the p walker, so eventually it calls do file. Yeah, you need this because of the Golang is so. But now we have a problem. We are trying to filter out some part here. That's why we have a string any. So let's just copy it. Yeah, so here is the string any. Let's just define it. So string any match any returns true if x equals to any of y. So we were using this to filter out directory, to filter out a list of expressions, regular expressions, list of strings to filter out. Okay, so let's just include that. And the to skip, well, the to skip, okay, let's include that too. Because I haven't coded Golang for a long time, so I don't remember. It'll take me a long time if I actually try to write it cleanly. So the to skip is empty, okay. Yeah, so go back here. So if string match any, skip, don't skip anything. So actually, so if skip, then the to skip. Actually, the whole part here can be empty. You know, we can just like, yeah, that will work, I think. But then Golang will complain when you have a function not used, or you know, Golang will kind of complain. So anyway, so else we don't want to skip any the. So else match string. So here it is actually using regular expression. File name rejects. Oh, this here is actually using this is to filter out file name path. Okay, so we need this file name rejects. Okay, so actually so we can define it here. Yeah, that will work. Yeah. Okay. So file name rejects then something to file. Okay, that's it. I think maybe we can try to run it. Now let's go to the main and let's see. Print if write to file, then print. We don't want to print, we don't care. Okay, done. Okay, so let's try to run this. What happens if we run this? Let's check one more time. Okay, first of all, let's try to back up, then Let's format the code. Okay, go format. Okay, done. Fantastic. No syntax error. So now those are the libraries we need. Input directory, file name regex. Okay, find replace pair structure. Then here's actual find replace pairs. Each one we are using this tick quote, which means literal. I believe I forgot. String. Okay, string / escape raw string literal. That's right. So that means literal string. That's right. So we don't need to escape regular expression stuff. Okay, then the to skip, which is nothing, it's a slice of string. We don't have anything. Is it used anywhere? Let's see. Yeah, it's used there. Okay. Okay, then string match any is a function. Okay, then we have the function do file. Okay, then we have the walker thing. Okay, I think we can run it. Let's copy the whole thing over first. Remove it. Copy them over. And now let's run this Golang. Run it. Finished. You see, it says finished. Now let's go to the directory. Let's see if it did anything. Open it. Fantastic! You see, that works. Now, list matching lines. That. Fantastic. You can see it did the change. Now, if we run it again, this will happen. You know, that random string will happen twice. Let's run it again. Okay. Close. Run it again. Finished. Open it. Open this. List matching lines. That, you see? Fantastic. One shot. There's no debugging. Now we can. Okay, now we can actually. So we need copy all. Put it back into our talk show, and now we need to create a new hold on a second, let's copy it here. So now we need to create a new file for the Golang so we can run it in the shell. So let's go here, remove the syntax following measure command. So this will be called go. Okay, and go. Yeah. So now we open that. Yes, create, paste previous. That's it. Okay. Save and close. Open. Fantastic. Close. Copy this line, and this window we don't need anymore. Close. Remove that. Okay, now we can paste here, run the Golang. Let's see how fast it is. Do it. Record breaking. The other ones are like 6 seconds, 2 seconds. Golang is 0.02 seconds. Jesus. Oh, Golang, my God. Now let's refresh. Okay, remove everything, copy them over, run the Golang. Oh my God, 0.02 seconds. Jesus, that's 30 times faster than any of the Emacs, Lisp, Python, Wolfram language. Now let's make sure it's correct. Okay, let's open this up. Oh, it didn't work. Fuck. It didn't change. What? Okay, this force excitement. Now, what is the problem? What is the problem? I don't understand. Let's open the Golang. Let's check. Oh yeah, because of course the Golang syntax, you are running Python. We are calling Python to run Go. Fucking idiotic. Okay, we need to fix that. So what is the command to run Go? Well, let's see. What is the syntax to run Go? That's part of my here. So Golang, I believe it's go run. Yeah, so you have to say go run. Okay, close. So you have to say go run. And where is my executable located? Get command go. There it is. Okay. It's very annoying because you want to see the full path. PowerShell is like, it's not showing the full path, but we don't need to. But one way you can do it is you can to show the full path is what? I believe it's full name there. Okay, I don't know. Let's go to PowerShell. For full name, why is it not? That should work. Why is it not? Yeah. Okay, so here is the full path of the Golang. Okay, doesn't matter. So now we just need to say go run. Yeah, so here. Okay, let's do it all over again. Remove the copy it over. Now run Golang for the first time. Four seconds. Now is it faster than the others? Let's see. Well, slower than Python. Jesus, what? Let's run the second time. The second time is 1 second. Okay, now let's go check the file to make sure it actually worked. Open it. You see it did. Now list matching lines, that you see it worked. You see. So when you run Golang second time, it's 1 second. Okay, let's do it again. Remove everything. Copy them over. Run Golang. 4 seconds. What? 4 seconds? That's even slower than Emacs Lisp. What the fuck? Second time is significantly faster. Okay, let's okay, now let's that's about it for today. So successful, fairly. I mean, even we did lots of talking and coding, but still successfully done. Go speed. So the first time is 4.6 seconds. That's unbelievable. The second time is 1.1. Okay. Now let's see. Okay, PowerShell, Wolfram language. The string we need to replace. Here's the result. Can you believe it? Slower than Python? I don't think so. I think our Golang needs to be improved. But however, the interesting part is when you run second time, Golang is faster than them all. Okay, that's it. Anyone still here? That's it for today. Thank you guys for watching. Buy my stuff, okay? Donate. Interesting. Yeah, very interesting. And I think tomorrow we're gonna continue. Thank you. We're gonna continue because right now there are more things to do. Okay, so right now this speed are reading 1,000 files, small files. We need to do one that is one single huge file, like we did before today, one single huge file. And also we need to increase the find replace pairs. Okay, let's increase them. Let's say, I don't know, let's say increase them to 20 or something. And let's see. So this is a very interesting problem. The problem seems simple, find and replace, but there's a lot of intricacies. There's a cache issue because reading file is the bottleneck. There's a cache issue. How do you know? The operating system already loaded them in memory. You don't know. So there's a cache issue. There's a writing to file issue. There's when there's no change, you don't want to write to file because that takes a huge amount of time. And then there's an interesting feedback loop problem, which all these languages, our code is incorrect except Wolfram language. Wolfram language is just superior that way. Then there's an interesting issue of the second time when you run it. This, you see, not current. The current result is interesting. You cannot say one language is better than them all, because right now, if you consider second time, Golang is faster than them all, and Emacs Lisp comes second. If you consider first time, then Python is fastest. Okay, so interesting. For some reason, the Python, the second time, it doesn't become faster. I can't, maybe we have some bug. So again, thank you, one of you who found a bug in Python. So if you have, look at the code, of course, just go to my website, you will find today's code and yesterday. I'll be moving all the code to today because each day we improve on this code. So you'll find the code and, do try to find a bug or do some improvement, and if you have a version, let me know, on Discord or Twitter, post to your Git. Let's find out, let's have a deep conclusion on which way is fastest and things like that. Okay, thank you guys. And I think that'll be it for now. Tomorrow I'm going to do something else. Tomorrow or next day, maybe take 1 day break. We're gonna do something else because we've been doing this for the past 3 days. So then we're gonna come back this and gonna have maybe some kind of final conclusion. And if you code Ruby or other language, post your code so we can compare. Thank you guys. Bye guys. So let me go put the, I'm shutting down. Okay, so let's put Golang. Let's go put the Golang code. Do we have Golang here? Okay, so open it, copy, close. Here, paste. Okay,